Number 1. Each year, billions of dollars are spent at theme parks owned by Disney, Universal Studios, SeaWorld, Busch Gardens, and others. A survey of 1,233 people who took trips revealed that 111 of them included a visit to a theme park based on data from Travel Industry Association of America. So A. Find the point estimate of the percentage of people who visit a theme park when they take a trip. Be P hat, because that's the whole population. So 111 of them included a visit to a theme park, which is going to be the X bar, and N is the total number of people, which is 1,233. And you're going to get a percentage of 0.0900 or 9%. So B, it asks you to find a 95% confidence interval of the percentage of all people who visit a theme park when they take a trip. So since we're dealing with a larger population, we're going to use one prop z interval. Okay, and we are going to input the information into which it asks, which is, so for one prop z interval, we have to input an x, n, and cl, which is confidence level. So x obviously is going to be 111, n is going to be 1,233 or 1,233, and the confidence level is going to be 0.95 for 95%. We hit calculate, and we get a confidence interval of 0.0741 in between the P for larger population to 0.106. That's going to be our confidence interval for B. And now we're going to continue on to a new slide so I can do number C. So C asks, the survey was conducted among people who took trips, but no information was given about the percentage of people who took trips for pleasure. If you want to estimate the percentage of adults who take a pleasure trip in a year, how many people must you survey if you want a 99% confident that your sample percentage is within 2.5 percentage points of the correct population percentage? So for this situation, we're going to use the program nprop. Okay, and then we're going to go ahead and input the information that it asks. So nprop, it's going to ask for z. So z is conducted by using the confidence level, which is 99%. So you do 1 minus 0.99 to get alpha, which is 0.01. Then divide alpha by 2, and you get 0.005. Then you do inverse norm, and that should give you z, which is going to be 2.58. Okay, so the P, since it's unknown, is going to be 0.5. That's just going to be given when we put in, and then E is also given to us, which is 2.5, which is the 2.5 percentage points of the correct popular percentage. And then we go ahead and hit calculate, and we should come out with a number of 266, and that's the minimum amount of people you should survey in order to be 99% confident that your sample percentage is within 2.5 percentage points of the correct population percentage. Number 5. Estimating ease of reading. Dataset 14 in Appendix B includes Flesch-Kincaid grade level ratings for works by Tom Clancy, J.K. Rowling, and Leo Tolstoy. If you want to estimate the mean of Flesch-Kincaid grade level ratings for pages from J.R.R. Tolkien's Lord of the Rings, how many pages must you randomly select if you want to be 90% confident that the sample mean is within 0.5 of the population mean? Because a sample of pages from Clancy, Rowling, and Tolstoy in Dataset 14 in Appendix B have Flesch-Kincaid level ratings with standard deviations of 2.45, 1.17, and 2.01. Assume that the standard deviation is 2.45 for Lord of the Rings. So, in this situation, we would use n-mean to find the sample size. So what we'll do is we'll input the first information, which is z, is what we're going to need. So in order to find z again, you do 1 minus the confidence level, which is 90% or 0.90. You get 0.1 and divide that by 2, and you should get 0.05. And do that, multiply that by inverse norm. You should get 1.64 as z. And from there, you go to standard deviation, which is given to you, and it is 2.45. And E, which is the margin of error, and that's also given, which is 0.5. So you input this all into your calculator, and mean, you hit calculate, okay, and you should come out with 64.57, and you round up to the nearest whole number, or next whole number, and you should get 65 as the sample.